What if I told you that the devastating path from simple forgetfulness to full-blown Alzheimer's disease could begin with the silent depletion of a single overlooked element in your brain? Welcome, my friends. Professor Vitalis here with your daily dose of wisdom and wellness, where science and experience walk hand in hand. Today, we are diving deep into a topic that touches millions of lives: cognitive decline. It's crucial that you stay with me until the very end of our discussion, because that is when I will reveal the precise form of this vital element that has shown the most promise in scientific studies, a form that works differently and more effectively inside our brain cells. The final piece of this puzzle is the most important, and you will not want to miss it. Let's begin by defining the problem. We often hear the term mild cognitive impairment, or MCI. What is this really? It's more than just the occasional senior moment. It's a noticeable decline in your memory, a slowing down of your mental reflexes, a new difficulty in learning new things. You might find yourself searching for words more often or rereading a paragraph because the information just isn't sticking. While a person with MCI can still live independently, manage their affairs, and even hold a job, there's an undeniable feeling that the mind is no longer as sharp as it once was. This change often becomes apparent to family and friends in people over 60, and sometimes even in those over 50. Now, why does this matter so profoundly? Because MCI is not a benign condition. It is a serious warning sign. The most terrifying statistic is that approximately 50%, 1 out of every 2 people diagnosed with mild cognitive impairment, will eventually progress to a diagnosis of Alzheimer's disease. This is a staggering number. It means that for millions, that initial fog of forgetfulness is the first step on a tragic journey. Alzheimer's itself is a catastrophic failure of the brain, a severe and irreversible condition where nerve cells, our precious neurons, are systematically destroyed. So how does this destruction happen? The hallmark of Alzheimer's is the accumulation of rogue proteins within the brain. You may have heard their names: beta amyloid and a protein called tau. Beta amyloid forms sticky, dense clumps between neurons known as plaques. Think of these as microscopic roadblocks, physically obstructing the pathways of communication. Meanwhile, the tau protein, which normally helps stabilize the internal skeleton of a neuron, becomes deformed and twisted, creating what are called neurofibrillary tangles. These tangles choke the neuron from the inside out. Together, these rogue proteins disrupt the elegant dance of electrical signals that constitutes our thoughts and memories, and they trigger a cascade of chronic inflammation that further damages brain tissue, leading to the devastating consequences we all fear. This brings us to a groundbreaking study, published in the esteemed journal Nature, a link to which I can provide if you are interested. Researchers embarked on a quest to understand the root causes of this decline. They hypothesized that perhaps a nutritional deficiency was at play. They took brain tissue from individuals with both mild cognitive impairment and confirmed Alzheimer's disease and meticulously tested for the levels of 27 different essential metals. They looked at iron, copper, zinc, all the usual suspects, but the results were astonishingly clear. Only one metal showed a statistically significant, consistent, and dramatic decrease across the board: lithium. This singular finding led scientists to a powerful new hypothesis. Could the deficiency of lithium within our brain cells be the very first domino to fall? The initial trigger that sets off the entire cascade, leading to memory loss, cognitive decline, and ultimately Alzheimer's disease. What they also discovered was even more fascinating. In the brains affected by the disease, the little lithium that was left wasn't freely available. Its distribution was completely skewed. It was found clustered and trapped around the beta amyloid plaques. Imagine you have plenty of money, but it's all locked away behind a thick, impenetrable concrete wall. The money technically exists, it's yours, but you cannot access it or use it for anything. This is precisely what happens in the Alzheimer's afflicted brain. The amyloid plaques act like magnets, sequestering the lithium and rendering it useless to the cell. So, the cell is simultaneously surrounded by these toxic plaques and starved of a crucial protective element. To confirm this link, scientists turned to animal models. In a carefully designed experiment, they took a group of healthy mice and simply removed lithium from their diet. The results were swift and dramatic. The levels of lithium in the brains of these mice plummeted by 50%. And what happened next is a chilling illustration of what lithium deficiency does to the brain. First, They observed the destruction of synapses. A synapse is the microscopic gap between two neurons. It is the physical bridge where information is passed from one cell to the next. The formation and strengthening of these connections is memory. If you lose your synapses, you lose your ability to form and retrieve memories. It is that direct. Next, the researchers saw the degradation of the myelin sheaths that wrap around nerve fibers. Think of myelin as the insulation around an electrical wire. If you strip away that insulation, the electrical signal, in this case the nerve impulse, leaks out and travels much more slowly. This physical degradation in the brain manifests as a tangible slowing of your reaction time and your overall speed of thought. You feel like your brain is running in mud, but that's not all. The study revealed something even more sinister. Lithium deficiency didn't just cause structural damage, it actively accelerated the very disease process it was suspected of causing. In these lithium-deficient mice, the brains began to accumulate beta-amyloid and a particularly toxic form of tau called phosphorylated tau. The phosphorylation of tau, the process of adding a phosphate molecule to it, is what makes it misfold and form those destructive tangles. And the key finding was that this entire process was supercharged in the absence of lithium. How? It turns out that a lack of lithium unleashes a destructive enzyme in the brain called GSK3-beta. When lithium is present, it naturally keeps this enzyme in check. But when lithium is gone, GSK3-beta goes into overdrive, frantically adding phosphate groups to tau proteins and driving the formation of tangles. Furthermore, the lack of lithium triggered rampant inflammation. It did this by abnormally activating a set of immune cells in the brain called microglia. Instead of protecting the brain, these activated microglia began to attack it, creating a chronic state of inflammatory stress. Finally, in one of the most compelling findings, the researchers looked at the transcriptome of the cells. What is a transcriptome? Imagine your DNA as a vast library of every song ever recorded. A transcriptome is like a specific playlist you create for a certain mood or activity, using only a select few songs from that library. It's the set of genes that are currently switched on and active in a cell. Astonishingly, the genetic playlist of the healthy lithium-deprived brain cells began to look nearly identical to the playlist of cells already ravaged by Alzheimer's disease. The very same genes that are active in the disease state were switched on by nothing more than the absence of lithium. Now, for the most hopeful part of this entire story. The researchers found that once they identified this cascade of destruction, they could reverse it. By reintroducing lithium into the diet of the mice, they were able to halt these age-related changes that were developing in the nerve cells. But here's the critical detail. What form of lithium did they use? It wasn't the high-dose lithium carbonate used in psychiatry. It was a special organic salt called lithium orotate. Why is this distinction so important? Because lithium orotate behaves differently inside the brain cell. Unlike other forms, it doesn't get so easily trapped and bound up by the beta-amyloid plaques. Remember our analogy of the money behind the wall? Lithium orotate seems to have a key to a side door. It can bypass the plaques and distribute itself evenly throughout the neuron, reaching the places where it's needed to perform its protective functions. The scientists tested several forms, and it was lithium orotate that came out as the most effective for this purpose. A fair question is, can we really apply these findings from animal studies to humans? The answer appears to be yes. We have large-scale epidemiological studies to back this up. Scientists have looked at populations around the world and found a consistent pattern. Regions where the drinking water and soil naturally contain higher levels of lithium have populations that live longer and have a markedly lower incidence of dementia and cognitive decline. Now, I know the moment you hear the word lithium, the question of toxicity and safety comes to mind. This is a very important point. The form we are discussing, lithium orotate, is typically used in nutritional supplements in microdoses. I myself, along with others in the wellness and longevity space like Brian Johnson, utilize a dose of around 1 milligram. To put that in perspective, this is anywhere from 250 to 1,000 times less than the doses used in psychiatry to treat conditions like bipolar disorder. At these tiny nutritional levels, studies in both animals and humans show it has no toxicity and, in fact, does not even raise the overall concentration of lithium in the bloodstream. And this brings me to a final, crucial point. The level of lithium in your blood has no correlation with the level of lithium in your brain. A blood test will tell you nothing about whether your brain has enough. The only way to know for sure would be to take a direct tissue sample from the brain, which, of course, no one is going to do. Knowledge only works when you apply it. I'm Professor Vitalis. Stay curious, stay healthy, and never stop learning.